We have seen that we can use prime factorization for three types of questions. First one, check whether the following numbers are perfect squares or not. Whenever you are given a number, we can check whether it is perfect square or not by using prime factorization. For example, first question we have 1296. So first step, you have to perform the prime factorization of that given number. Here we have 1296. So do the prime factorization. After completing the prime factorization, you have to express it into the product of prime factors. So resolving into prime factors, we can write 1296 as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, and then make pair of each number. Then after that we can see that here all the numbers are formed pairing, so therefore 1296 is a perfect square. Since 1296 can be expressed as a product of pairs of equal factors. Here all the numbers form pair, so therefore we can say that the given number 1296 is a perfect square. Now from this, if it is a perfect square, we can easily find the square root also. That we will discuss in next question. Now second example, 1575. So here also perform the prime factorization, and then after resolving into prime factors, we can see that 1575 is equal to 3 into 5 into 5 into 7. 3 into 3 into 5 into 5 into 7. Now when you make group, we can see that here 7 is left unpaired. Here 3 and 5 form pairs of equal factors, but 7 is left unpaired. So we can say that this is not a perfect square. Grouping the factors into pairs of equal factors, we find that 7 does not form a pair. Therefore, the given number 1575 is not a perfect square. So this is the first type, checking whether the given number is perfect square or not. So first step, do the prime factorization, then resolve into prime factors, then make groups. If all the numbers form pairs of equal factors, then we can say that the given number is a perfect square. If any number is left unpaired, for example in this question we can see that 7 is left unpaired, 7 is not having a pair, so the given number will not be a perfect square. Now next, second type. Find the smallest number by which the given number is multiplied by or divided by to make it a perfect square. So you will be given a number. We have to find out by which number, smallest number by which the given number is multiplied or divided by to make it a perfect square. So the given number may not be a perfect square, and what is multiplied or divided by that given number to make it a perfect square. So here also our first step, perform the prime factorization. Then second step, resolving into prime factors. Then third step, make group. So here also we can see that after resolving into prime factors, we can see that 2700 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5. And after making group, we can see that here this 3 is left unpaired. So we can say that if you divide 2700 by 3, then the resulting number will be a perfect square. Otherwise, if you multiply by 3, then also the resulting number will be a perfect square. So grouping the factors into pairs of equal factors, we find that 3 does not, here 3 don't have a pair, so 3 does not form a pair. Hence the given number 2700 can be multiplied by or divided by to make it a perfect square. Clear? Now we can see what will happen when we divide or multiply. Now here 2700 can be expressed as a product of prime factors like this. Then we can see that if you divide by 3, then what will happen? This 3 will be cancelled. Then we have only 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 into 5. Then all the numbers will form pair, and then we can see that if you divide by 3, we will get a 900, and its square root will be 900 will be a perfect square, because here we can see that when you express 900 as product of prime factors, then all the numbers form pairs of equal factors. So square root of 900, since it is a perfect square, we can find the square root. It will be 2, from this pair 2, from this pair 3, and from this pair 5. This 3 is already cancelled by division. So we will get answer 30. Now instead of division, if you multiply, what will happen? If you multiply by 3, then additional 3 will form a pair with this 3. Then we can say that 2700 when multiplied by 3 will become 8100, and it will be a perfect square. So its square root will be 2 into, from this pair 2 into, from this pair 3 into, then this 3 also formed a pair after multiplication, then that 3 into 5. So 2 into 3 into 3 into 5, answer will be 90. So if a given number is not a perfect square, perform prime factorization, resolve into prime factors, and find out the number which is left unpaired. Then that will be the number by which the given number is multiplied or divided by to make it a perfect square. Clear? Now we will go to the second example, 9408. Here also perform the prime factorization, and after that resolve it into prime factors. Here also we can see that when we make a pair, we can see that this 3 is left unpaired. So grouping the factors into pairs of equal factors, we find that 3 does not form a pair. So we can say that the given number is either multiplied or divided by to make it a perfect square. So if you multiply by 3, then this 3 will form a pair. Then we can find the square root and also the number, resulting number. Resulting perfect square also we can find. If you divide by 3, this 3 will be cancelled. Then also we can find the resulting perfect square and its square root. So here 9408 when multiplied by 3, we will get 28,224. It is a perfect square and its square root will be 168. Same way 9408 when we divide by 3, we will get 3136, which is a perfect square. So its square root will be 56. Now third type is very simple. Find the square root using prime factorization. For finding the square root, we have two methods. First one is prime factorization method and second one is long division method. Now here we are going to see how can we find the square root using prime factorization. So first example, 3249. So first do the prime factorization. Then when we start writing answer, we have to put the square root sign. Since we are going to find the square root, we have to find the square root of, we have to write square root of 3249. And in the square root sign, we have to resolve the given number into prime factors. So we know that 3249 is 3 into 3 into 19 into 19. So that can be written like this. Then next step, you have to form group, making pairs. Okay, after that what we have to do is from each pair From each pair, pick out one factor. So from this pair of 3, we can write 1 3. From 19, we can write 119. So please be careful when we go to the next step. From each pair, when we pick one factor, then no need of root sign. So it will be 3 into 19, and 3 into 19, it is 57. So we can say that square root of 3249 is equal to 57. Now another example, we have 1764. Here also perform the prime factorization. We can see that 1764 is equal to 2 into 2 into 3 into 3 into 7 into 7. And here we can say that we can see that all the numbers form pairs of equal factors. So here 2 is having a pair, 3 is having a pair, and 7 is also having a pair. So therefore we can say that the given number 1764 is a perfect square. That's why we can find the square root. So finding the square root, we can start with square root of 1764 is equal to square root of, resolve the given number 1764 into prime factors. We can write 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7 multiplied by 7. Then making pairs of equal factors. After that, when we start finding the square root, we have to pick one factor from each pair. So from this pair, we can take 1 2 outside. From this pair, we can take 1 3, and from this pair, we can take 1 7. So we will get 2 into 3 into 7, which is equal to 42. Therefore, square root of 1764 is equal to 42. So these are the 3 different types of applications where prime factorization is used.